Let's start with chromatography. Chromatography is a method of separation in which the components to be separated are distributed between two phases. One of these phases is called stationary phase, and the other one is mobile phase, which is moved on stationary phase in a definite direction. Commonly used for separation, identification, and determination of the chemical component in a complex mixture. Mobile phase. Mobile phase is a medium which the mixture to be separated moves in particular direction. It is either a liquid or gas which is passed through a chromatographic enzyme, where the components of the mixture are separated at different rates by adsorbing to the stationary phase. What is stationary phase? Stationary phase is a bed or support substance that are fixed. It is composed of either a solid or liquid substance attached to a glass or metal surface on which the components of the mixture to be separated, and there are numerous stationary phases. There are some type of chromatography. First is column chromatography, paper chromatography, thin layer chromatography, gas chromatography, and lastly is high performance liquid chromatography.
Chromatography is based on the sample is dissolved in a solvent and washed through a stationary phase by a mobile phase called eluent. Competition between the sample molecules absorbed by the stationary phase and dissolved by the eluent results in separation. Substances that are more soluble in the eluent and less absorbed by the stationary phase move faster through the apparatus. Speed of the substance passes through depends on the nature of the stationary phase and the eluent. So, what is liquid chromatography? Liquid chromatography is a technique for dividing a sample into individual components. The sample interacts with the mobile and stationary phases, resulting in separation. Because there are many stationary and mobile phase combinations that can be used to separate a mixture, there are several types of chromatography that are classified according to the physical states of those phases. To check the water quality, we use high-performance liquid chromatography, known as HPLC. HPLC is an important environmental analysis tool because it allows for precise, accurate, and sensitive measurements of various pollutants and contaminants. Its ability to separate, identify, and quantify a wide range of compounds makes it useful for evaluating water quality, monitoring air pollutants, detecting pesticides in soil, and analyzing waste. HPLC also detects and quantifies contaminants in water samples, including heavy metal, pesticide, organic compounds, and endocrine disrupting chemicals.
Next, the methodology of HPLC. There are 7 steps to follow. First is preparing for the mobile phase. For instance, 60% acetonitrile and 0.1% trifluoroacetic acid in water. Before use, filter and degas the mobile phase. Next, column details. For example, 150 mm long, 4.6 mm internal diameter, 5 micrometer particle size C18 column. Step number 3 is flow rate. Set the flow rate to 1 milliliter per minute. Then, injection volume. Inject 20 microliter of each sample and standard. For the next step is temperature. We need to maintain the column at 25 degrees Celsius. Step number 6, detection wavelength. For UV detection, set the wavelength specific to the analyte. For example, 254 nanometer for common organic pollutant. And the last step is runtime. Typical runtime may range for 15 to 30 minutes depending on the complexity of the sample and the number of analytes.
Lastly, I am going to explain on how to read the chromatography result. Firstly, as we can see, the diagram showed what a typical chromatogram looks like. The Y vertical axis represents as mole. Mole equals sign to milliabsorbance unit. Mole indicate the absorption of analyte. It is also used to determine the concentration of the analyte. Okay, now let's check the horizontal axis, which is it represents retention time. Retention time is the time between the injection of the analyte into the detection of the analyte. Now, you can check compound S, which has a retention time of 6 minutes. Retention time can also be used as an identification tool. So what is the identity of compound S? As we can see based on reference list of compound and retention time, it is caffeine. Let's check the concentration of caffeine, which can be determined with the calibration curve. Let's check the example calibration curve. Prepare sample and run HPLC analysis as follows samples. C1 50 mgl, sample C2 100 mgl, sample C3 150 mgl, sample C4 200 mgl, and sample C5 250 mgl. As concentration increases, the peaks become bigger and higher. Then we can do a simple calculation as the diagram. The peak area represents the amount of compound that has passed the detector. So a higher peak does not mean the concentration is higher. Peak A has a higher concentration compared to peak B, as the peak area of the peak A is larger. Let's have a look at the calibration curve. With this information, we should be able to calculate the concentration compound S, which is equal sign to 207.757 mgl. The peak area of compound S can also be calculated by the computer program. If the software calculates everything, why bother looking at the chromatogram? We want to make sure our analysis is done correctly by looking at the chromatogram.
As a conclusion, we can say that high-performance liquid chromatography (HPLC) is a powerful analytical technique that can make precise separation, identification, and quantification of complex mixture with high sensitivity. It is also help us in study and check the quality of water. This helps us to make sure the water we use is clean and doesn't have things like toxic or heavy metal that could be bad for our health.